In this video, we're going to be talking about cells and structs data types in MATLAB. After watching this lecture, we should know how to create a cell data type in MATLAB, then how to manipulate cells in MATLAB. We should also learn how to create and manipulate structs in MATLAB. To this point in the class, we have talked about Boolean, numeric, and text types of data types. What we have seen is we can make arrays composed of Boolean, or numeric, or text. We have not learned how to make arrays that combines these two. In this class, we'll be talking about the heterogeneous containers where we can put all types of data types together inside either a struct or a cell data type. The first heterogeneous data type we'll discuss are cell arrays and how to create them. A cell array is a data type which is an indexed data container called cells, where each of those containers within the cell may contain any type of data, whether that be a double, an int, a struct, another cell, or even char arrays. A cell can be created using the curly braces operator, and like all arrays in MATLAB, a cell array must be rectangular, where the same number of cells are in each row, or the same number of rows are in each column. So we have m by n cell arrays that we can make using our cell operator. Let's take a look at how this is done. We've learned previously that we can make doubles, and by default, MATLAB will assign any numerical value to an array as a double class. So if I was to make an array called double var and assign that the cell 1, 2, 3, the array 1, 2, 3, we know that this variable will be of class double. We've also learned how to make arrays of char arrays, so I could make my char array and A, B, C using the single exclamation point. So we can make a char array. But what we cannot do is we cannot combine these two arrays together. Now, we can combine arrays if they have matching sizes of the same class by concatenating. So I could concatenate my double array, I'll just do double var, with another row vector, so let's say 4, 2, 5. And since these are of the same class, we can concatenate them together. And we could also make a new character array with a concatenation, and we could concatenate another row vector, so other char. And we can do this concatenation because they are of the same class. But when they are of different class, we get unexpected results. And so if I wanted to do combine double and char, so let's just try to combine those two. I could try to concatenate these, but what we'll see is that we have a result that is unexpected. And so what we have is the double array, when concatenated with the char array, became some garbled, unreadable thing, and we actually lost, if we take a look at this, we lost the values as a double. So we try to pull that out. We no longer have the first value in the double var, and we know that that is the value 1 if I were to pull it out of there. So we lost the double that was stored in there when we tried to concatenate them. So we can't do regular array concatenations in MATLAB with different classes of variables, but we can do it if we create a cell which will put a container for the different types of arrays, and then we can access those. So I could make if I wanted to retry, I could take another stab at this, but create a cell. So The curly brace operator works quite similar as the brackets in that it uses commas or spaces to do rows and then semicolons to, commas and spaces to do columns and then semicolons to do a new row. So I could do something like this. I could do, let's actually just re-type this in. But I'm going to get rid of those brackets there. And so when I type this in again, and I don't need the comma, but I'll put it in here for clarification, what we see is we got a 1x2 cell array. And the information is preserved. So let's talk about next how we can actually get our information that is within inside our new cell array that we created. So there are two different ways to access data inside cell arrays, which is unlike our regular arrays. The standard smooth parentheses, like we do if we were going to access data within a double array, so like let's just say I wanted to get the thing in the first row and the third column in this double array, we can also use the parentheses to access things within a cell array. MATLAB calls this smooth parentheses cell indexing. So I can say my cell, and since my cell is a 1x2 cell, I could say my cell, and let's get the thing in the first row and the second column of the cell. And what it actually returns is another cell. So actually, when you're using a smooth parentheses, I actually advise against you using this because what you're doing is you're getting a peek into what's inside the cell. And let's actually take a look at my cell. Inside the first cell is a double array, and inside the 1-2 cell address is a char array. And so what we've gotten is another cell that contains the char array. We can't actually access that char array. The other type is the curly brackets. And so this MATLAB calls is the content indexing. So this allows us to get the actual content that is inside the 1-2 address of our cell. So when we type this in, instead of getting another cell, what we get is an actual char array. See what our ANS is now was a char, where before ANS was a cell array. So if you want to get the actual contents inside the cell, you have to use the curly braces indexing. If you just want to see what's in that cell or see the cell, then you can use the smooth brackets. For the most part, I recommend you use the curly braces if you're trying to access the data. And usually that's what you're trying to do when you're using cells, is you're trying to get the data or manipulate the data within inside the cells. So the curly braces is the way to go. Let's take a look at some more complicated examples to understand how the creating of cells and accessing of cells works. So now that we've learned both the smooth parentheses and the curly braces where we actually have the content of a cell, let's actually learn what is called multi-level accessing of a cell. And this can actually go several levels deep. But let's just actually think about what's inside our first row and first column, or element 1 in our cell. We've seen before using the smooth parentheses that that's going to be a 1x1 cell, but what is inside that 1x1 cell is a 1x3 double. So we can actually modify what's within that by using multi-level indexing. So we could first just access that by using the row column, or we could even use the column indexing. So that first index would just be 1, and that gets us the double. But what if we wanted to get the value 2 out of there, just 2? Well, if we thought of this as a 1 by 2 double array, we would know that we could get the 2 out of that array. In this case, it's been assigned to A and S by saying row 1, comma 2. We could have also just said 2 using the column indexing. We could also, if we knew that this was of length 3, we could say end minus 1. There's a lot of ways we could have done this, but I'll just do the column indexing to get our value 2. If we'd like to actually pull this out of the cell and not the entire array, so just that second second item within that double array within our cell, we first call the cell address, and what's important is that we must use the curly brace indexing because we need to first access what's in that cell. So it doesn't work if you use the smooth braces. We can almost think of this as a variable name now in our head for whatever resides within this first address of our cell. And then we can index on top of that using, since it is a double array, using a double indexing array of just these smooth brackets. And so we could say row 1, comma 2. And what this will pull out is the 2 within that double. So this part of our multi-level indexing refers to that we are accessing the thing in the first entry of the cell. So this first cell of my cell, or the variable called my cell, which is of class cell. We saw that the class of that is a double, and then what we're going to do is access the thing in the first row and second column. This will give us the value 2. So this is how we can use multi-level indexing. We could have also used it to get part of the phrase from the char array. So I can say my cell, comma 2, and then we could get items, let's just say 1, 2, 3. And that would give us the ABC part of that array. So a word of caution is if we were to relook at this statement, if we had used the smooth braces when we were first addressing the cell, remember that this is just going to give us kind of a peek. It's not going to actually get us the contents within that cell. So if I would have tried to do this multi-level indexing, but using smooth parentheses, then what we would have gotten is this would not have worked because there isn't a third entry within that cell because that's a 1 by 1 cell. So this is going to give us an error because we're not actually indexing this the way we think we are. We don't have the thing within that cell, we just have a 1 by 1 cell. So this would not work. So make sure if you're trying to access stuff within a cell, use the curly braces indexing first. So that would be something like this. Let's take a look at some more examples. So let's create another cell. Let's call this one just, I guess, cell 2. And in cell 2, what we're going to do is we're going to create, let's just put 1, comma 2, and then 3. So I'm actually saying there's going to be 3 different columns, and then on the second row, I'm going to actually put our first cell, the let's just say 1, 2, 3, which is a double, a 1 by 3 double, and then let's put let's say my char array 2. So so what we're going to be creating is a 2 by 3 cell. And so within this cell, I'm calling it cell 2, the first row has all kinds of things. So if I want to look at what's in this first row. You can actually see, I'm going to preview here. I have a 1 by 1 double, a 1 by 1 char array, another 1 by 1 double. I have actually another cell within a cell. It's almost like cell inception, and we're going to try to figure out, this is where it can kind of get head scratching. But remember, that's the beautiful thing about cells, is that we can throw really anything we want inside them. It's just a container for other data types. We're not doing it in a particularly organized fashion right now, but you can actually use it in a more organized fashion. But I want to show you how to access all of the things within this, regardless of the type. So we've got another cell within our cell. We've got a 1 by 3 double, and we've got a char array. And that char array turns out to be 1 by 12. And so we know within my cell, because we've already looked at it, we had our ABC other char, and we also have the 1, 2, 3 double array. So we know that's what actually exists within that cell. So what if we wanted to get that 1, 2, 3 within my cell, within cell 2? So to do that, we can use multi-level indexing. If we wanted to address this specific cell within cell 2, what we would do is say cell 2. And there are two ways we could do this. This could either be, if we're using column indexing, remember we go index down the column, so this would be entry 2, or we could do row 2, comma 1, either would work. And so this would actually, and I'll just press enter so you can see, will retrieve what is within that. And what is within that, what we placed, was a 1 by 2 cell. So let's take a look at that. And then that's got our 1 by 3 double and that other char array. And we can actually get the stuff within that cell, because really this is just another name for that cell. And to get stuff within a cell, we know we use curly brackets. And so let's just say I wanted to get all the stuff within this first cell entry. I can do 1, and I'll just be consistent since I'm using row and column here. I'll be consistent. And that's going to get us the whole double array within that. Of course, we could have done this just using column indexing. And you can also use logical indexing with cell arrays. Okay. And if we wanted to, say, reassign, let's say this 3 to be something else, we can do that using our multi-level indexing. So we would say the third entry here, assign to that, in this case, the value 4. And so if we take a look at our cell 2, then we can actually dig inside that 1 by 2 cell, and we see now that we have within that actually assigned that 4. Or we can actually just print back out to the screen what is in there. So that is 1, 2, 3, 4. So that is how multi-level indexing works. There can be as many cells as you want buried within or nested within other cells. An interesting thing that comes out of cells really being a container for anything you want is that concatenation oftentimes will work where our concatenation using our traditional double arrays would not work. Like, for example, we know that if we tried to concatenate fail, let's just try to make a variable that is going to be concatenating our double variable, which is a 1 by 3, with itself transposed. So let's say double var and then itself transposed. And we know that this would fail. We know this would fail because the size of this is a 1 by 3 and the size of this transposed is a 3 by 1. And the reason it would fail because there are not the same amount of rows and columns in each one. And so it would fail. It would not be able to concatenate these two because they aren't of matching size. But if we want to create our cell, and let's call it cell 3, whatever. Let's concatenate my cell, and then also, comma, my, let's say cell 2. In this case, we can concatenate these two together because it doesn't matter. It's that these two are of different size. We know that cell 2 is a 2 by 3 and my cell is a 1 by 2. It doesn't matter that they're different size because they're both going to be put within their own container. And so cells are really generic in that way. We do, though, however, have to still create rectangular cells whenever we're doing concatenation. So that is one thing that you have to look out for. Here I created a 1 by 2. If I would have added another row, but only put one element, then it would have failed. So if I did something like this, and then just put, let's just say, my, can really be anything, so it could be just a char array, it's going to fail because it's going to stack on top of two cells. It needs, if it's going to add another row, there to be two columns in that, and I only have one thing that it's going to put in there. So we still have to create rectangular cells. The first code word for this video is going to be sour. The next heterogeneous data type I'd like to talk about are structures. So a structure is an array that is a data type that can actually group things together based on data containers called fields. And so the syntax for any structure or struct in MATLAB is the structure name. So here I just have it as camel case, but this could be anything as long as it's a valid variable name. And then dot, so this dot notation means that the thing that's going to follow the variable name for the structure is the field within that structure. So this is the syntax for this. I'm only showing you this because I want you to know about structs existence within MATLAB. But when we come back to a topic later in this course called object-oriented programming, there's a more sophisticated way to do this, creating things that are called objects. And so in general, structs are not extremely useful. And if you're trying to make a struct, it turns out objects are better because it's harder to mislabel a field. And in this case, you could create any field name you want. And so we'll come back to learning object-oriented later in the class. But for now, I want you to know about structs. And so any of the fields could contain any type of data. So just like a cell, this has the potential to carry heterogeneous data types, but in a more organized fashion. And so let's just say, for example, we had a patient, and maybe we had some medical data where we knew the patient's name, we knew maybe their billing, how much they were going to pay for something that they did in an office, and then maybe some test scores that they had done on them. And so within that patient, we could have a field that represents their name, a field billing that is how much they are owing, and then another field dot test that has whatever test scores that the patient had. And so this could be one part of a struct. So let's look at how we could make a struct containing these different fields. So to create this struct, we're going to populate the fields. And so we don't have to pre-allocate it, just like creating any type of variable in MATLAB. So I could type in patient1.name. So patient will be the name of our struct, and then .name will be the field. In the smooth parentheses here is the address, meaning that in the first instance of this field name, we're going to put a char array John Doe. And so now you can see that we've created a struct, which is 1 by 1, That's because there's only one field in it, and there's really only one patient within this patient struct. So let's take a look at our struct. And so we see that we have one field, that is name, and then just one value within that field. We could create another patient, and if we want to put that in the same field as the name, but in this case, this is Jane Doe, we can take a look at our struct. It just became a 1 by 2. And that's because within those fields, we now have 2 patients within that patient field of the name. We saw that patient 1 had some billing of 127, presumably dollars. So we can enter that in. And now what we see, our patient struct is still 1 by 2, and that's because there's only 2 patients currently in there. If we wanted to add another patient, we could just create a third patient. And so we could do, this is going to be patient 3 in the dot field address, and we'll call this other patient. I'm feeling very creative right now. Okay, one thing you noticed is when we created Jane Doe, we didn't have any billing information, so MATLAB just put an empty cell, or sorry, empty brackets, which is basically a empty array for billing. So there is no billing, but we know that we could actually populate that billing address at a later time. This is now a 1 by 3, and just like MATLAB before created an empty bracket under billing for Jane Doe, it has now done that for our other patient. If we wanted to create our field for test scores, we would just use the same thing where we have the name of the struct, and then we need to create a new field, so dot test scores. So dot test in this case. And what we put in there, so what we see is the struct, it could contain cell arrays because within the name field we have a char, sorry, not cell, a char array. Within billing, we have a 1 by 1 double, and within test, we have another double array. In this case, it was a 3 by 3. The empty containers have been put in as placeholders for Jane Doe. To access any data within a struct can be done using multi-level indexing similar to cells, but we still use the field. So for example, if I wanted to see what patient 1's test scores were, I would do patient 1 dot test. And that would put out what is in that field within this struct. If, however, I wanted to get the first row of the test scores, this is where it looks similar to the multi-level indexing, is that now this test is actually sort of a name placeholder. This is almost like a valid variable name for this 3 by 3 array. And so to get the first row, I'm just going to put the, and since we know this is a double array, we can use the smooth brackets. And within that, to get the first row, we could do row 1 and then all columns, so the colon operator. And this would retrieve that first row. We can, of course, assign to it using a similar methodology. So as long as we have a matching size array, so I could do 1 step by 2 to 5. Okay. What you see here is that that test value has been changed. So if I look at it again, we've actually changed that by assigning a new value to it. The second code word for this lecture is going to be the word journal. So now that we know how to create define and access data within structs, let's take a look at multi-level indexing when it comes to the combination of any array, be it double or a character array, a cell, or a struct. So first I'm going to create a double array called my_num. And this will just be my 1 to 2. I could have used colon indexing for this. I'm going to create a cell, a 2 by 2 cell, and within that, sorry, a 1 by 2 cell. So in the first cell entry, I have a char array with the value 1. Well, it's actually the char string O, N, and E. So this will be a 1 by 3 char string, and another 1 by 3 char string in cell 2 of my cell, and I'll put the value 2. So I'm going to redefine my cell to be that. And then I'm going to create a struct with the entries, or actually what I'll do is I'll concatenate the struct that we've already created called patient with these cells. And so I'll create some variable C, and then let's make a cell where we put in it, because remember, we can put anything within a cell. So we could put my_num, we could put my cell, and then we could put the struct patient. Okay. And so what we're going to create here is a 1 by 3 cell. And in that, we have a 1 by 3 double, a 1 by 2 cell. Within that 1 by 2 cell, we have the char arrays, and then a 1 by 3 struct, which is the patient struct that we have just constructed. And so if we wanted to access data within the struct within the cell, or data within the cell within our cell, so the data within my cell within the cell array C, what we're going to have to do is use multi-level indexing. So for example, we know that we can get the name of our second patient by doing patient and then 2, and then dot the field is name, and so this should give us Jane Doe. But how would we get it out of the cell C? So maybe pause your video and see if you can come up with how to do it. Okay, so if you've taken a stab at that, we know that patient is within the third cell, the patient struct, that is, within the third cell of C. And so we can't use the smooth brackets to get that, because we actually have to get in there. So remember, that is the curly brackets to actually get the structure within the cell. And we can either use the row and column indexing, or we could just use the column indexing. I'll use row and column. And then what this represents is actually sort of a placeholder for whatever is here, and then we can tag on any addressing after that. And so what is here is actually a placeholder for patient. So actually you could sort of replace this in your mind with a multi-level indexing that would be equivalent to the variable name of our struct. Just to prove that, let's take a look at what this is. And so this will give us a struct with the fields as so. And so if we wanted to get Jane Doe out of that struct, we take this cell multi-level indexing and basically replace, so this right here would be our multi-level indexing. And so we can just append, so this will be the second part, and then the field. And so that will give us Jane Doe. Okay. So that is how we could do multi-level indexing with a cell within or a struct within a cell. Hopefully that is helpful. For now, this is all we'll need to know for our cell and struct arrays, and then we'll come back and learn a better way to do structs when we learn object-oriented programming later in the class.